Okay, in this video we want to verify the trig identity cosecant squared x times the quantity 1 minus sine squared x is equal to cotangent squared x. And step one in verifying trig identities is always to pick the more complicated side and make that your given information. So I'm going to go ahead and jot down my goal up here in the corner, which is to make the more complicated side match cotangent squared x. And then I'll just label this first step as my given and save myself some space. Okay, then I want to recall my trig identity hexagon so I can remember the fundamental trig identities. So tangent is the quotient of sine divided by cosine, and then we use the reciprocal identities to fill in the rest. So cosine's reciprocal is secant, sine's reciprocal is cosecant, tangent's reciprocal is cotangent, and the center always gets a 1. Okay, so looking at my given information, I see Pythagorean identities. Anytime you see something being squared, it should make you think of a Pythagorean identity. And those Pythagorean identities, if you recall, are in these triangles here. So sine squared plus cosine squared equals 1. That's one of our identities. Tangent squared plus 1 equals secant squared. That's another Pythagorean identity. And then 1 plus cotangent squared equals cosecant squared. That would be the third. Okay, so if I take a look at this 1 minus sine squared, and I know that the sine squared x plus cosine squared x equals 1. That's my Pythagorean identity from the hexagon. If I were to solve this for cosine, I would subtract sine to the other side. So that means that 1 minus sine squared x is equivalent to cosine squared x. So I'm going to make that substitution. So I'll start here with my original cosecant squared x, and then that's going to be times, but instead of 1 minus sine squared, I'm going to apply that Pythagorean identity that we just discussed, and I'll have cosine squared x now in the parentheses. And the reason for step number 2 then is applying that Pythagorean identity. Okay. So now I'm left with a product of the cosecant squared x times the cosine squared x, and on the trig identity hexagon, my product identities make hinges. So for example, sine is the product of its left and rightmost vertex, so tangent times cosine is sine, right, because the sine is in the middle. Cosecant times tangent is secant. So if I locate cosecant, it's here, and cosine is here, those are the left and rightmost vertices with respect to cotangent. So the product of cosine times cosecant is cotangent, and that means that I can apply a product identity to this product, and I'll end up with the cotangent squared of x. And that was using a product identity. And now we're done that quickly because we've reached our goal, which was to show that the more complicated side was equivalent to the cotangent squared x, and we've done it, and so this is verified.